Assalamualaikum and hi. So today our group, which is group 4, will be presenting our problem-based learning questions for subject Algebra and Calculus. So our group members is me, Nurdia Shadira binti Nur Rizwan, number matrix AA250582. And then we have Siti Nur Ishira binti Idris, Nur Soraya Nasihin binti Muhammad Jamsari, Nur Alia Safia binti Azan Shah, Siti Nur Shahira binti Aris, and lastly, we have Zaizwani binti Zailani. So, introduction for this problem-based learning questions and problem is the application of differentiation in real life. Differentiation is a mathematical technique used to determine rates of change. In this presentation, we apply differentiation to first, fuel consumption in a moving vehicle. Second is cooling efficiency. So the objectives for this problem-based learning is to find velocity and acceleration, to analyze fuel consumption rate, to determine the optimal fin length, and lastly, to interpret the results graphically.
Assalamualaikum. My name is Siti Nushaira binti Aris. My matrix number is AA250755 and I am from section 6. Today I will explain about question 4.1a. For question 4.1a, we are given the displacement equation of car, which is s bracket t equal to 10t square minus 0.5t cube. This equation represents the distance travelled by the car after 30 hours. For this part, we need to find two things, which are the velocity and acceleration of the car after 2 hours. First, we need to find the velocity first. We know that velocity is the rate of change of displacement. So we need to differentiate the displacement equation. After differentiating, we get v bracket t equal to 20 t minus 1.5 t square. Next, to find the velocity after 2 hours, we substitute t equal to 2 into the equation. So v in bracket 2 equal to 20 bracket 2 minus 1.5 bracket 2 square, which give the answer 40 minus 6 equal to 34. Therefore, the velocity after 2 hours is 34 kilometers per hour. Next, we need to find the acceleration. Acceleration is the rate of change of velocity. So we differentiate the velocity equation again. After differentiating, we get a bracket t equal to 20 minus 3t. Then we need to substitute t equal to 2. So we get a bracket 2 equal to 20 minus 3 bracket 2. So we got the answer 20 minus 6, which is 14. So the acceleration after 2 hours is 14 kilometers per hour square. In conclusion, after 2 hours, the car is moving at 34 kilometers per hour and accelerating at the 14 kilometers per hour square. That's all for question 4.1 part A. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zaizwani binti Zalani and my matrix number is AA250917 and I'm from section 6. So now I'll be explaining for question 4.1b. For question 4.1b, we need to determine the rate of change of fuel consumption after 2 hours. Since the fuel consumption rate is proportional to the vehicle's velocity, we first use the velocity function obtained from the displacement equation. After substituting the proportionality constant, which is 0.05 liters per kilometer, we obtain the fuel consumption rate function. Then we differentiate the fuel consumption rate function with respect to time to find its rate of change. By substituting t equals 2 hours into the derived equation, we get a value of 0.7 liters per hour square. Therefore, the rate of change of fuel consumption after 2 hours is 0.7 liters per hour square. This indicates that the fuel consumption rate is increasing over time. Next, for question 4.1c, the graph shows the relationship between velocity and time. At the beginning, when time equals 0, the velocity is also 0, indicating that the vehicle starts from rest. As time increases, the velocity increases steadily, showing that the vehicle is accelerating. The graph reached its highest point at approximately 6.67 hours, where the maximum velocity is about 66.67 kilometers per hour. After reaching this maximum point, the velocity begins to decrease, indicating that the vehicle is decelerating. Finally, velocity becomes zero again at approximately 13.33 hours, which means the vehicle comes to a complete stop. Overall, the graph demonstrates that the vehicle accelerates initially, reach a maximum velocity, and then gradually slows down until it stops.
Assalamualaikum and good day everyone. My name is Siti Nanshira binti Idrus and my matrix number is AA250168. Now, I will explain section 4.2 which is cooling fin efficiency. The objective of this problem is to find the optimal fin length X that maximize the heat dissipation. Firstly, the heat transfer rate of the cooling fin is given by the equation Qx equals to 120x times e to the power of negative 0.1x, where Qx is the heat transfer rate and x is the fin length in centimeters. To determine the fin length that gives the maximum heat transfer, we will use the differentiation and find the critical point. The first step is to find the first derivative, q prime of x. Since the function consists of two terms multiplied together, which are 120x and e to the power of negative 0.1x, so we need to apply the product rule. So we let u equals to 120x and v equals to e to the power of negative 0.1x. Then after differentiate, we got u prime equal to 120 and v prime equals to negative 0.1 e to the power of negative 0.1x. Then we will substitute it into the product rule, which is q prime of x equals to 120 times e to the power of negative 0.1x plus 120x times negative 0.1 e to the power of negative 0.1x. And then we will simplify it to become q prime of x equals to 120e to the power of negative 0.1x minus 12x times e to the power of negative 0.1x. So, after simplifying, we will be factoring out the common term e to the power of negative 0.1x, and we will got q prime of x equals to, in bracket, 120 minus 12x times e to the power of negative 0.1x. So, this is our first derivative. Next step is to find the critical point. To find the maximum point, we set q prime of x equals to 0. So we got the equation 120 minus 12x in bracket times e to the power of negative 0.1x equals to 0. Since the exponential function e to the power of negative 0.1x is always positive and can never equal to 0, therefore we only solve 120 minus 12x equals to 0. Next, move negative 12x to the right hand side, giving the equation 12x equals to 120. Then, to get x, we move times 12 to the back, and it will become 120 divided by 12, which is equal to 10. Therefore, x is equal to 10 centimeters.
Hello, my name is Noala Safa Binta Zansha, Geometry AA250566. And for this slide, we are verification of maximum points. To verify x10 is a maximum points, we analyze the signs of the derivative q prime x in bracket. So for x less than 10, q prime x in bracket greater than 0, so the function is increasing. For x greater than 10, q prime x in bracket less than 0, so the function is decreasing. Since the function changed from the increasing to decreasing at x equal to 10, so the point is a maximum, so the final answer is x equal 10. Therefore, the optimal fin length that maximizes heat dissipation is 10 cm. For this slide, for B digital test, plot graph Q bracket in X in bracket digitally and mark the maximum point interpret physically. So first, we differentiate qx in bracket. So q prime of x equal 120 e to the power of negative 0.1 x and times bracket 1 minus 0.1 x, and then after that we set q prime of equal to 0. So next we substitute into the equation. So 120 e to the power of negative 0.1 x times bracket 1 minus 0.1 x equal to 0. And then after that we solve for x. 1 minus 0.x equal to 0, and final answer is the x equals 10 lah. Step number 2, we substitute x equals to 10. So substitute x equals 10 into the original equals. So x of 10 equals 110 and 20 times 10 times e to the power of negative ones. Step 2, calculate the value. The value of q of 10 is approximately 441.46. Step 3, state the maximum points. Therefore, the maximum point is 10,441.46. And then step number 3 is graph observation. So the graph increase as x increases. So the maximum points occurs at x equals 10. After x equals 10, the graph decreases. So step 4, physical interpretation. A long fin increases the heat transfer at first because it provides more surface area. However, when the fin become too long, its tips become cooler and less effective at transferring heat. Therefore, the most efficient fin length is 10 cm. 10 cm with a maximum heat transfer rate of 411.46. So the conclusion is the cooling fin achieves its highest heat dissipation at 10 cm. Beyond this length, the heat transfer rate decreases, making the fin less efficient. That's all.
Assalamualaikum. My name is Nur Soraya Nasim binti Muhammad Jamsari. My matrix number is AA251269 and I am from section 5. So for the conclusion, this project demonstrates how the differentiation can be used to solve practical real-life problems. For the vehicle model, we found that after 2 hours, the car velocity is 34 kilometers per hour and its acceleration is 14 kilometers per hour squared, and the full consumption rate is 1.7 liters per hour squared. For the cooling fin model, the optimal fin length was found to be 10 centimeters, which gives a maximum heat transfer rate of approximately 441.46. Overall, the result shows that the differentiation is a useful tool for analyzing change, finding optimum values, and improving efficiency in engineering and transportation application. That's all from us. Thank you.